Good morning, everyone, and welcome to our Jamaica Observer Online Study Center workshop. And we are so happy that you guys decided to join us. We're so happy that you registered. Or for those presents who didn't register, you still have time. So we'll be having a link popping up periodically, and you can click the link so you can get the workbook that we'll be using today. Now, we want to thank everyone for joining us, parents, teachers, and students of all ages, because everybody can do CSEC, even when you pass high school. Today, we are going to be doing mathematics with our master teacher, Mr. Jimmy Hilton. Before we go on, though, we want to thank our sponsors, Sagicor Jamaica, Tasty Jamaica, and Phase 3 Productions. And also, before we move on, we want to encourage you to like, share, and subscribe to our YouTube channel, Observer Clips, and follow us on all social media platforms at Jamaica Observer. So now we turn over to our master teacher, Mr. Jimmy Hilton, as he takes you through the day.
What's up, guys? Peace. Enough respect. Big up. Welcome back to the Jamaica Observer Study Series, free CSEC online workshop. I'm enthusiastic to be with you again this year. It's enough niceness, and it's time to get active, right? If you are not active, get your pens, calculators, graph papers ready, because we're going to be having some fun for the next 2 hours, okay? For the first part, I'm going to be going through some study tips. Very important. Study tips important. Part of the reason why students do poorly in CSEC mathematics is how they approach the exam. So we're going to be going through some of the tips that can allow you to get a 1 in the exams. And the 2 topics that we're going to be looking at today, we're going to be looking at vectors. And for the second part of the class, we're going to be looking at transformation geometry. 2 topics that are normally very easy because they are visual topics. The exam normally comes with the graph with these diagrams, so you just need to figure out how you approach it. So without further ado, we're going to be going into the PowerPoint presentation, into the tips that you need to know how to be a successful math student. Because for many of you, you always approach the exam the wrong way, and as a result of that, you do poorly in the exams, right? And let me empathize with you out there as far as the COVID crisis is concerned. Because of the presentation, I took off my mask. Remember, the government said that you should always wear a mask, keep safe, and during this crisis, be strong. A lot of us are depressed and down, but I'm here to tell you that in spite of that, you can do well in your examination. You just have to believe in yourselves, and you got to do a lot of practice and also do the best that you can. Believe in yourself. So without further ado, I'm going into a PowerPoint presentation that has to do with some tips that's important that you should practice in order to be successful in mathematics. Okay, so the first tip that we are going to be looking at is that mathematics is a practical subject. And because it's a practical subject, then we should always practice, and more practice. It is not something that we can read, and that is part of the challenge with a lot of us. We do not do a lot of practice past paper questions, practice basic questions, and it is impossible to study mathematics properly, right? By reading and listening. You have to practice, right? You have to dedicate the time to do as even 2 or 3 questions per day. The more you practice answering math problems, the better you are. So that's the first thing we look at. The second thing is that very important in mathematics. The second tip is that we should what? We should review errors, mistakes that we make. Many times, students, they go into the exams and they make mistakes into the exams. During practice time, they did not take it out of their way to ask the teacher or the person who is teaching you mathematics, where did I go wrong? When you're practicing these problems, it's important that you work through the process of each of the solutions. So when you run, you practice first, and then when you practice, you review the errors that you practice, right? If you make any mistake, you should review them and understand where your problem-solving skill falls. Okay, so review your errors. That's the second tip. The third tip is that you should master the key concepts. key concepts. So if you are doing fractions, for example, if you're going to look at the concept of finding the LCM and also dividing, right? So it's important that you understand the example I give, understand the key concepts. Not memorizing a process, but understanding the key concepts. Do not try to memorize the process, right? This is counterproductive. It is much better and rewarding in the long run to focus on understanding the process and logic that is involved, right? This will help you to understand how you should approach each problem in the solution. So it's important that you should master the key concepts, all right? The next important study tip is that you should understand your doubts. So the areas that you have problems with, you should understand where these problems are. And doubtfulness sometimes come across where students actually work out questions and they are not sure whether or not they are wrong or right, right? Sometimes you have to, if you get stuck to solve part of a math problem and find it difficult, right? It is difficult to move on to the next stage. So it is common for some students to skip this question and continue to the next. It's like a give up, right? You should avoid doing this and instead spend time trying to understand the process of solving the problem. And that is where people become impatient. And you cannot be impatient with mathematics, right? Remember that math requires time and patience to master. Okay, the next skill is that you should what? Very important skill, create a distraction-free environment, right? You have to concentrate when you're doing mathematics. You cannot create an environment where there's a lot of distraction, because you have to concentrate. It's important, right? And a proper study environment and a distraction-free area, right? The phones can be a source of distraction, especially in these times. So we have to spend less time looking on the phones, going on social media, which I know you want to communicate with your friends, but once you do math, you have to concentrate on what you are doing. And you have some problematic topics like geometry, algebra, and trigonometry, which if you do not concentrate while you are studying, then you will not understand the concept or you'll become frustrated, right? Create a maths dictionary, terms that you are familiar with that you're not sure about, and research them. It's important that you create a math dictionary. And the last one, second to last one, apply maths to real life situation. I'm sure you have heard persons say, boy, maths out the thing, right? Maths is logic, maths is reality. So it is important that you try to see how maths apply in real life. A lot of persons will find the excuse of saying, boy, the simultaneous equation that they are doing, they don't see how it applies out there. But the fact of the matter is the mathematical process involved in your brain is highly improved with the use of mathematics. So just one quick thing before I move to the presentation, some strategies that you must practice quickly, and I'm going to go through them quickly. You should last 5 years of past papers, you should try and get them, right? Because from the last exam going back 5 years, both multiple choice and paper 2, get the answers, look at how the questions are structured, and that's what you practice from, because 10 chances to 1 these same questions will be coming back. Your study session should be 45 minutes with a 15-minute break. Do not go over an hour. You become saturated and you reach a point where you stop learning, right? So it is like you're wasting time, right? Practice at least 9 hours per week and try to find positive people to study with. Because trust me, I know a lot of persons don't like mathematics, but timetable it during the week. Don't just study it at random. Find timetable, I say, every Monday evening, such time to such time. And I understand some of you are working people, but the fact of the matter is if you want to be successful, you have to find, it's a relationship, right? Group study, if you can't study alone, right? Try and find some group to study with so that you can, some persons find it difficult to study by themselves and they become demotivated. Now we have internet, we have social media, we have different platforms that we can use. We can create our own Google Meet where we invite our friends for a session. We have YouTube, and we have other areas that we can use to get information from. So we can't just roll over and play dead. And that is part of the reason why persons, and I know the COVID crisis would have allowed a lot of us to be down and depressed, but guess what? There is still hope, right? Know your learning style, meaning that you must know what type of, the way in which you get information, which one of them appeals more to you. Are you somebody, are you a visual learner? That means you learn from a lot of pictures. Are you somebody who, auditory, meaning that if you are talking with somebody, you can grasp information quickly? Are you somebody, if you go on YouTube, then you learn from the video more than somebody actually talking to you? Find out the type of learning style or the thing that appeals to you mostly, and use that as an avenue to boost the way in which you understand the mathematics, right? Last one, which most of you should just eat properly. Avoid sweets, avoid foods that are not necessarily brain food. And at the end of the day, guys, in closing, I hope you do well, and just be positive, and just believe in yourself, because confidence is important in this subject here, right? Thank you very much. So I'll be moving on now to vectors, and vectors is a topic that is a visual topic. Basically, it deals with visuals. This is a example of a vector line that we draw. A vector can be represented with components. So what I'm going to be doing, I am going to be going through a short PowerPoint presentation on vectors, and then what I'll be doing, the Jamaica Observer would have sent you a workbook online, and I'll be going through a few of the questions. I won't be able to go through all of the questions, but for the first part, we're going to be going through some of the basic things that you should know about a vector and how the questions could be asked during the examination so that you can approach a question and get 100%. Because the way you approach a question determines how well you answer the question. All right? So it's important that you approach a question in a positive way. So without further ado, I'm going to be going straight to the PowerPoint presentation. Okay, so for the PowerPoint presentation, okay, what are we going to be looking at? We're going to be looking at okay, we're going to be looking at PowerPoint. All right, so we're looking at define what a vector is, the column notation for a vector, the multiplication of a scalar vector, negative vectors, additional vectors, subtraction of vectors, and problem solving with vectors. So we're going to be looking at some of the skills that's involved in vectors. So let's move on. All right, so the question is, what is a vector? Theoretically speaking, a vector is just a line with a name. It has a starting point and an ending point. Let me go through that again. A vector is just a line. Now, I don't want to define it too much. Let's say in mathematics, we have scalar quantities and vector quantities. The physics persons, yes, that is more applicable to them in a general way, but we just want to concentrate on how we're going to approach this question in an exam. So a vector is a line. All right, and what does this line consist of? It consists of what? That's a line. That's a line. And what does it consist of? Consists of line as a name, right? So if it's PQ, that's the name of the vector PQ. So we can call it based on the starting point and the finishing point, because you'll have noticed that it has a starting point and it has a finishing point, okay? And it has a body. All right. So we have vector PQ there. We are looking at vector PQ, and we are looking at vector RS. So the body of the vector PQ is called A, and RS. So if you notice for PQ, right, it has two components. It has the 3, if you know that the 3 runs horizontally, right? It's horizontal, and the 5 runs vertically. So those would be the two components of the vector, right? So the vector, right? Vector, right? The vector is P, Q, right? A, right? So look at this now. The vector can be referred to as A or PQ, and this is saying this is the starting point for the vector. It's a line, and the components of the vector, horizontal, vertical, basically, right? So that's what a vector is. It's just a line, right? So the question is why this line causes so much problem. So I'm going to go back. So let's go back to the PowerPoint, and I'll tell you why it caused so much problem. I'm going to tell you why it caused so much problem. The reason why it caused so much problem is that the fact that first, in the examinations, right? Look at this one. Look at the first one, and look at the second one. The second one, notice. All right? Look at that one. All right? And the components for that vector is what? 4, 5. So look at this now. And the name of, what is the name of this vector? The name of this vector is RS. Okay? Now, in the naming of a vector, students, there are some things that we need to take into consideration, and we have to do the direction. So if we start here, what we do, we form what is referred to something like a right angle triangle to get the vector. And the other two sides would form what is referred to as the components of the vector. Now, we call this the directional key. Directional key. So if you are going up on the horizontal, if you are going up on the vertical, then it's positive. And if you are going down, right, on the vertical, that's negative. Right? If you are going to the right on the horizontal, if you are going left. So for example, look at this one now. Look at this, right? This vector now. We are going from R to S. So if we are going, so we are going this way. So we are going positive. So that's why the 4 is positive, and we are going down 5. So that's why the name of that vector is 4 minus 5. Now this one, this is positive going to the right, positive going up. So that is why the components for this vector, both of them positive. So based on this rule here, right, if you are going up, it's positive on the horizontal, okay? Horizontal, going, and we say up and down is relative because, you know, okay, so let's go again now. So I make sure that we get it the right way. That's the horizontal, and that's the vertical, right? So we're going down, that's negative, up, that's positive, right? So we're going this way, it's negative, going that way, it's positive. Okay? All right, so just remember that. And this is important when we are doing the vectors. So let's go back to the PowerPoint. So, so if you notice, all right? Well, I use 5, so that's why my one is 5, all right? But it is still negative because you are going down, okay? All right. Now, so the top number describes the horizontal movement, which is positive means to the right, negative to the left, as I was explaining here, right? While the bottom number describes the vertical components, positive means up, negative means down. All right, just remember that? Okay, so let's move on. Let's cut this one. Right? Now, So we move on from the components of a vector to the scalar of a vector. When we look at this vector, realize that a vector has components and a vector has also scalar. What do I mean by a scalar? All right, so let us look at a basic example. Let's look at this. Let's call this A. And this could be 3A, right? So what does that mean? The 3 refer to the scale of the scale, which means how much the vector is increased by or decreased by. Because if it's a whole number, it is going to be increased by. If it's a fraction, it's going to be decreased. So for example, this is 3 times this. But we can also have half A now. And half A would be possibly this. So the number beside the vector is referred to as a scalar of the vector. So let's go down. Let's continue. So if you notice this one, it's 3B. All right, so the vector there is B. Okay. All right, so let's move on now to a situation, the inverse vector. Inverse vector, so what we have looked at so far, we have looked at the components of a vector, the scalar of a vector, and what inverse vector. So what the inverse vector means that if we have that vector, let us call that A, and we have the same vector going in the same components going in opposite direction, then it's minus A. All right, so that's inverse vector. I mean, this is going same size, but it's going in the opposite direction. So this one is referred to as the inverse vector. So let's go on. Quickly. All right, inverse vector. Switch it back to the other one. Okay, all right, so let's move on now. All right, so we're going to be looking at now, what I'm going to be doing, I'm going to be going to the Jamaica Observer, I'm going to be going to the Jamaica Observer workbook. I'm going to be looking at how, because it's a workshop, so I'm not actually here to teach you the concepts, generally speaking. What I'm here to do is to go through some of the questions and see how you would work out the questions in a real life situation. All right, so I'm going to be going to the Observer workbook. All right. And that's the Jamaica Observer workbook. All right, then we have a question here. Okay, I don't know if you are seeing it there. You are seeing it on the screen? The Jamaica Observer, yes. And this is the workbook that would have been sent to you online, that one. So we're going to be going through a few questions with this one, okay? So let me do this question with you. Okay, let us look at this question and see how we would approach this question. So the question is asking us for the components. It is asking us for the components of the vector. Let me write it up a little more that you can see it. All right. All right, and then if you are seeing it very well, where you are, so we want to find the components of the vector here. So it is asking us to find the components of the vector. So let us look at this one. It starts here and it ends there. Starts there and it ends there. Okay? So to find the components of the vector, it would be, so if you notice, that would be 1, 2, 3. But we are going in that direction. Right? We are going in that direction. So it would have been minus positive 3, because we are going to the right, and we are going down. So it would have been 1, 2, 3, 4, 5, 6, minus 6. Those are different. So the components for that vector, let me go through it again, let you see it one more time. components for that vector. Looking for the first, we want to work out the first vector. The first one, first vector. So it would be using, it would be 1, 2, 3, and you are going to the right. So if you are going to the right, it's positive 3, and that's on the x-axis. And you are going down, which is negative on the y. So it would be 1, 2, 3, 4, 5, 6. So that would be the components of that vector. Okay? Components of that vector would be 3 and 6. 3, positive 3 and 6. Okay? I don't know if you have seen my screen very well. You see my screen okay? Okay, all right. So I have to make the screen a little smaller, no problem. Okay. Let me just go over that again, make it right that you can see it. Let me do the second example. The second example is this one. Second example is this one that is there, that one. So first reformer starting, that's 1. That will be 1, and it's going to the right. So because it's going to the right, it would be 1 on the positive 1 on the horizontal, and we are going up 1, 2, 3, 4, 5, 6. Positive 6. So that will be the component for the next vector. Let me go through that one more time. That's the second vector there. Second vector. That's this one. That's 1. Right? And then we're going up 1, 2, 3, 4, 5, 6. Positive 6. So it's 1, positive 6 for the answer for that one. Okay? Okay. Yeah. All right, let's move on to the next question. Let's move on to the next question, which is the other okay. Let's go on to move on to the next question here. Next question here. We're going to look at this quickly and then we move on to the next component. Let's look at this one. Walk me a little wider, make you see it. Let's cut this one. Okay. So let's look at that. All right. What I'm going to do, I'm going to come back to this. I'm going to do the actual components on the graph. I'm going to actually do the components on the graph. Okay, you want me to go back to the slideshow? Let me do that quickly. Let me go back to the slideshow quickly. Somebody's asked me to go back to the slideshow. So let me just do that quickly. Let me just do that quickly. I hope you'd have received the workbook. The workbook, because the workbook has a lot of questions in it. Let me just go back to the slideshow quickly. Let me just go back to the slideshow quickly. Somebody was requesting that I go back to the slideshow. Okay. Slideshow. Go back to the slideshow quickly. Are you seeing the slideshow? Okay, so these are all of the concepts that we need to know. Defining what a vector is. We're writing the vector in a column. So let's go quickly. I would say if you're talking about vector PQ is a line. Basically, starts from P and end at Q, right? And that's a vector itself. It's a line. Start at P and end at Q. And then there's another vector beside it, which is RS. And basically, the vector, it has a body, and you can either call it by the starting point or the ending point or the body. They call it head or tail or the body. And the vector consists of a horizontal component and a vertical component. The horizontal component would be the 3, and the vertical component would have been the 5. That is what the vector is. And those two make the components of the vector. As a matter of fact, what I'm going to do, since I'm right there, so let me just use that stone and kill this bird. Since I'm right there, going back to that same vector PQ, A. So I'm going to use that stone and kill this bird. So they could ask it to find the length of the vector, 3, 5. Yeah. They could ask to find the length of the vector. Right? Or they could, that's another way they could ask you to do it, to find the length. Length of the vector or the size of the vector. So in that case, you just use this formula, the square root of x squared plus y squared. Very simple. So this is x, or horizontal. So the length of the vector would be equal to the square root of what? 3 squared plus 5 squared. What's the square root of 3 3 is 9? So it'd be what? 3 3 is 9, 5 5 is 25. Square root of what? 34. And that would be the answer. Right? Okay, that would be the answer for the, which is about 5 point, maybe about 5 point, square root of, it's close to 36, which is 6. So maybe it's about 5.8 units. Right? Maybe close, because 6 is 36. All right. So if they ask to find the length, so if they give you the components of the vector and ask to find the length of the vector, you'd use this formula to find the length of the vector. So since I go back, I'll give you some addition so that I don't have to go to that. Yes, so let's move on to the other part of the thing that some persons were saying that they missed. The body of the vector, and we said that the vector, it has a starting point and an ending point. Starting point, and we say we have to use the directional keys. The directional keys, when you go up on the vertical, it's positive. Down on the vertical, it's negative. My right here, it's positive. It's negative, sorry, I'm going to the right there, it's positive, okay? I use that to assist you to know that, like for example, like this one, we know that we go there and we go there. So this is positive and that is negative. So that is why we end up with that there. Okay? All right. I don't know if that cleared up that for the gentleman who, thank you for asking that question online. Basically, so we say the so second there, right? So we say that the, going back to the PowerPoint, yes. So we say that the, as you would have seen with the PowerPoint, the components of the vector, the top number represents the horizontal, bottom number the vertical, right? And we looked at scalar. The scalar is a number that is used to describe two vectors in terms of one compared with the other, right? Here, B is 1/3 of 3B, right? And basically, that's the relationship there, all right? So I think we could, okay, if we multiply a vector by a scalar, that's how we increase the size, and that's how it is showing here. The end there would be the scalar to the vector, okay? So I would say the inverse of a vector is a vector with the what? Same size, but going in the opposite direction. The inverse of a vector, same size going in the opposite direction. Let me see if I can do this, because some persons are having difficulty seeing my screen. Some persons are having difficulty seeing my screen. Let me just go to that one quickly. Right. That one, seeing it, supposed to be able to see it a little better? Right. Right. So if we take the negative of a vector, same as reversing, so that's the inverse of the vector, if you notice, it's going same size, but it is going in the opposite direction. Okay? All right. And that one is basically showing you that all of those vectors have the same size. And that is basically showing you the different comparisons between the different vectors there. We'd have seen A compare with 2A, and that is basically explaining the concept of scalar. All right. Okay, let us look at this one now. Let's look at this one quickly. Adding vectors. Let me just do it on the board, and then we can go back to the past paper, because that is what we want to look at. We want to look at some of the past paper questions. So I'm not going to spend a lot of time teaching. I'm going to be spending more time, see if we can go through as much of the questions in the booklet as possible. So let us look at these two vectors. A is 3/5. A equals 3/5 and 0.5. B is 4 minus 4. And let's say we should add A and B. Now if you notice, okay, let's look at that. One is A and one is B, okay? So let us say if this was A and this was B. So let us say that was A and B. I wanted to go from A to B. If I want to go from there to there, then of course you'd have to go in the opposite direction here and go in that direction. Right? So if you don't want to move from here to here, you'd have to go opposite there, which is changing the signs. That's what we call the concept of inverse vectors. So that's why you'd have to go in the opposite direction there and go in the right direction there. So that is what is it on the PowerPoint, as you see on the PowerPoint. All right, so let's go back to the PowerPoint. As you'll have seen, A, B, you're adding both vectors there, that is how we get that A plus B. All right, let's move on to the, we're going to move back to the paper. We're going to be moving back to the paper. The paper, okay. All right, so let's look at the paper. And I'm going to be looking at question number 2. So I'm going to look at question number 2. Question number 2. Okay, so let's look at question number 2. And it said we should represent those. All right, let me just draw this down. Negative. Okay, so it says represent these graphically on the graph. Graphically on the graph. And these are free vectors. Because free vectors means you start anywhere. Right? So it's the first one, it's 2 units on the horizontal. So I'm going to be doing it on the I'm going to be doing it on the graph paper that you are seeing here. So let me use white, because white can be, so you can start anywhere. So let's say I start there. Let me use that. Let's say I start there. So it's a 2, 5. 2, 5. So the 2 is positive and the 5 is also positive. So it's 2 is positive, that means we'd have gone 1, 2 on the horizontal and 5 on the vertical. So it's 1, 2, 3, 4, 5. So this is our starting point. So this will be the vector. Sorry, let me use a straight line to do it. Let me use a straight line to do it. So this is our starting point, and that will be our vector. And that will be the answer for 2, 5. 2, 5. So it's 2 on the horizontal and 5 on the vertical. Let's look at the one with 4 and minus 4 and 3. Minus 4 and 3. So we must have a starting point. Minus 4 and 3. Minus 4, so we have a starting point. I'm going to use white, minus 4. All right? So minus 4, this is the starting point. So you move minus 1. Minus 1 means that you're going to go down on the x. You're not going to go up. So it's minus 1, minus 2, minus 3, minus 4. And you're going to go 3 up. Because the 3 is positive, so you're going to go up. So it's 1, 2, 3. The 3 is up. So what you're going to draw the vector now, starting point, ending point. Right? So that's how that one will go. Are there any questions to be asked from persons out there that I can? Any questions to be asked? Any questions to be asked with what is happening so far? Okay. I think we get the gist. Let me do, and this one, of course, this one is minus 4, 3. All right, so let me move on to the other one, the two problematic ones. You have two problematic ones with common exams, and that's D and E. D and E, where it says D, let's look at D. D says, D is asking you to draw 0 and 3. All right, that's D. All right, 0, 3. Now, if you notice, 0 means there's no movement on the horizontal axis. There's no movement on the horizontal axis. No movement. 0 means no movement on the horizontal axis. But you have 3 on the axis. So let us say this is a starting point. Let us say this is a starting point. Starting point. There is no movement on the horizontal axis, but we have 3 and the 3 is up. So it's 1, 2, 3. So the vector for that would be, we're going to draw a straight line for that. Right there. And that would be the vector. And that's 3. 0, 3. And if they'll ask you for E, you'd approach it the same way if they'll ask you for E. If they'll ask you for E, E is 3, 0. E is 3, 0. So that means you must have a starting point for E. Let's look at E. Looking at E. Looking at E. 3, 0. So let us say that is starting point for. So you have 3 movements on the horizontal. We're looking at the one for 3, 0. That's one. So there's 3 means 3 units on the horizontal, but none on the vertical. So it'd be 1, 2, 3. And then you draw it. You draw it. You use your, I'm going to use my thing to draw it, straight line. Straight line to draw it. That's it. So let's move back to the. Okay, yeah. All right, so let's go back to the past paper. Let's look at number 3. Number 3 is, let's look at this one for number 3. Number 3. That's number 3. All right, number 3 is stating that given a point 1, 3, find P, Q. So for this, you'll have to draw something like a graph paper. You have to have this on a graph paper. Okay, have something like this on a graph paper. So let me see if I can sketch a graph paper quickly. That's very easy. Just use a line to do it. Okay. Okay. So so using what is there, using the, say, So this is 1, this is 2. What is 1? Graph paper, I need to move the graph paper up, so I'm going to do that. Move the graph paper up. But you can see the graph paper. So let me go back to 1. So it's 1, 2. Everything here is positive, so not to worry. All right, so it's 1. There'll be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so it's a point P, 1, 3, that is P, x equal 1, y equal 3. X equal 1, y equal 3. Right there, x equal 1, y equal 3. And the other one, that will be P. Okay, and the other one, Q, 4, 5, x equal 4, y equal 5. Right there. All right. All right, I don't know if you can see it a little better there. Let me just draw it up some more. Okay. So I'm just write the 2 a little better. Okay, that is 1, 2, 3, 4, 5. And it's what? PQ. PQ. So we're going to draw the line PQ. And that is Q. PQ. That is PQ. So the question is asking us now. What is the question asking us? The question is asking us to put in the direct. It's very important that you put in the direction on it. Right? Okay. The question is asking us to determine what is PQ and determine the length of PQ. Right? Determine what is the components of PQ. Once you see that, it's asking to find the components of PQ. So let us look at it from what is there. All right? From what is there, if you're going to travel from P to Q, right? Then you will look at look at it carefully. What are the components of PQ? So you would create a right angle triangle for the components. So let me draw that and make you see it. So you would write the rubber off. Right? So you would, for the components, so it's what to be 1, 2, 3, and you're going that way, and you start in here, it would be 1, 2. So it would be, so PQ is equal to 3 units on the horizontal and 2 units on the vertical. Straightforward. It will be 1, 2, 3, and 2 units on the. So then you have to draw the graph paper to do that. And it asks us to find it. It asks us to find this, PQ, which is asking to find the length of PQ. So to find the length of PQ, you find the square root of 3 square plus 2 square, which is equal to the square root of 9 plus 4. Right? That's the square root of what? Square root of 13, and that would be the answer, square root of 13. All right? Square root of 13, 3 3 is 9, 4 4 16, about 3.5, 3.6, somewhere there. So that's how you'd work out that one. Any feedback on that one? Everybody okay? Feedback on that one? Any feedback on that one? Any feedback on that one? Everybody good with that one? Okay. So let's move on to another example. Because as I said, we want to look at some of the issue is the workbook, and the whole idea is to look at some of the questions from the workbook, right? Going down through the workbook, most of the questions are like that. Basically, number 3 and number 4 is basically the same type of question. Let us look at a concept that we had not looked at before, and it's a concept of. So basically, in summarizing this part, on the graph paper, you will be asked to be able to identify the coordinates of the points, and that is the coordinates that you use now to find the components of the vector. But because I'm not going to go through another example again, I'm just going to go back to the question we did a while ago, just for emphasis again, just one more time. Let me just go back to the question. It says, given the points 1, 3, and 4, 5, all right, determine the components of PQ and the length of PQ. So to find the components of PQ, if you notice, we would have drawn our graph and identify where P is and where Q is on the graph. Okay? And then we draw the start, and then we'd have realized that to move from P to Q, right? P to Q, switch back. Based on the graph paper. All right. All right, so I think we've got 3 components here and 2 there. So that is why PQ is equal to 3, 2. This is positive. This is positive because we're going that way. And this is positive because we're going up. Right? And it's to find once you see this, it means you must find the length of it. So it's equal to square root of this square plus 2 square. Square root of 9 plus 4. That's the square root of 13, and you work that out. All right? Okay, so we're going to move on now to the concept of, we're going to move on to the concept of, we're going to look at question number 5, concept of parallel and collinear. We're going to look at the concept of, because that always comes on the exam. That always comes on the exam, the concept of collinear and parallel. Now, before we do that, first we have to understand what parallel means. Parallel means 2 lines that are equal distance apart, okay, in the general context. So there must be some relationship, and normally the relationship comes in the form of the gradients. In vector, is no different. The only difference is that you have to sort of figure out what the gradient is. So we're going to look at an example here. I'm going to do it and let you see it. So I'm going to be doing this question. Let's just look at this question. And there's a little error with this question, which I'm going to correct. Okay. It's supposed to be 6b. So in your book, please correct it to 6b. Let me just put it on the board that you see it. It's actually 6b. There's an error in the book. There's an error, so please make the correction in the book for me. Please and thanks. All right. And the question is 5a plus, you must show that they are parallel. And the 2 lines are, I think it's CD. 5a plus 2b, that's CD, and EF is equal to, please make the correction in your books. It's supposed to be 15a plus 6b. 15a plus 6b. Please make the corrections in the book. It's not 15a plus 5b. It's not that. So please make the correction in the book. All right, so the question it is asking to prove that these two lines are parallel. In order to prove that they are parallel, we just need to prove, right, that they have the same factors in both, right? Right? The coefficient multiplies the factor. So the factor here is 5a plus 2b. So we can rewrite this. Okay, if we use 3, we can get 3 into 15 was 5 times, and 3 into 6 goes 2 times. And what do you notice? That EF is 3 times this. And with 3 times, basically, EF is really 3 times the size of what? CD. If you look at it. Because CD is this, and when we factorize EF, we get this, which is basically the same thing as CD. So how do we prove? Because these two have similar coefficients here, they are equal. Right? So that is why EF, therefore, would be parallel to CD. Let me run through that again quickly. From start, the question is asking, you must prove that these two lines are parallel. And I said make the correction in your book, because in your book you have 5b here. It's actually supposed to be 6b. Okay? So what we do, we already have, we rewrite EF to make it look like CD. And we get this, 5a plus 3b. So realize that this and this is the same thing. So based on what we had said earlier, this would be like a scalar, right? So this would be 3 times the size of this, okay? So from that, both lines are parallel, all right? I don't know if anybody want me to go back through that again. Any feedback on that one? Any feedback on that one? Anybody want me to go back through that one? Right, because I say it's a workshop, you know, so it's us working possible questions that will come in the exams. It's not really a teaching moment per se. But if you want me to go back through it, that's okay with me. And to prove that these two lines are parallel, you just need to convert them to have similar components. And because they have the same components here, then basically they are parallel. So for argument's sake, let me see if I can say it another easier way. A and 3a would be parallel because they are common, a is common there. All right? If you had, for example, a plus b and 2a plus 2b, right? If you had, for argument's sake, if this vector the name pq and this vector the name rs, and it asks to show that they are parallel. This is ab. When you rewrite this, you could get it as 2 ohm bracket what? A plus B. So automatically say A plus B there, say A plus B there, that makes them parallel, basically. All right? Okay, so let's move on to another example, and as we're looking at possible questions that can come in the examination. I don't know if anybody want any feedback from that one. All right, let me move on to another example. Ask about collinear. There's another example there. All right, let me do that one. Let me do number 6, and it says 5-4. I think there's an error there again too. It's supposed to be 8b. Let me do that one quickly. It's supposed to be 8b. It's supposed to be 10a plus 8b. Let's look at that one. One more example. One more example. As we say, it's a workshop. We want to look at, after this, we look at the collinear. And it's after we're done the collinear, I'm trying to see if I can rush and do the collinear because we have a few minutes left. We have approximately about 12 minutes left. But I can do the second example. It says 5a plus 4ab (5a plus 4b), okay? And EF, not EF, CD, so it's a proof that those two, and make the correction for me, please. It's supposed to be 10A plus 8B in your books, and not 10A plus 12, 10A plus 12B, right? It's supposed to be 8. Okay, please make the correction in your books as well. That's another error there. Sorry about that. So what do we do? Look what we do again. We can rewrite this to look like this. We can use 2. So it's an EF equal what? 2. 2 into 10 goes 5 times. And 20. Huh? And what is AB? What is AB equal to? Now 5A plus 4B. So therefore, because these two have the same components there, then EF, therefore, EF is, and we use the sign for parallel to AB. Done. Simple as that. All right, so we're going to look now at the last thing, which is collinear. Last thing we're going to be looking at is collinear. And collinear means that they lie on the same line. Okay? Looked at parallel, collinear, collinear work. Now, in order to prove that they are collinear, then what you need to prove is that there, if you were to break up the lines into any two parts, there is a geometrical algebra relationship between them. Okay? It's similar to parallel. It is similar to parallel. Similar to proving parallel, but just that is a little bit more in depth. Collinear means all of them lie on the same line. In other words, then, let me see if I can. If you have A, B, C, that means collinear. That means all of them lie on the same line. So all you need to prove that there's a relationship between, for argument's sake, say AB and BC, because they're on the same line. Or you need any two pieces, or you need to prove that AB is related to what? AC. Yeah. You just if you break up the line in any two pieces and prove that there are any two parts of the line, there's a relationship there. Okay? So let us look at, there's a question there that, let me see if we can go back to the question. Question number, what was it again? Question number, what was it? Now might be the collinear. Normally with collinear, all right, it's half A, right. If they can use the two words, they can use collinear or on a straight line, same thing. Because if you notice, AB, straight line, ABC. So the question is, how do you prove it? So let us look at question number 7. Question number 7. AB is equal to half A plus 1/3 B, and BC is equal to 2A plus 4.3B. Prove that they are collinear. No problem. That's going to take a little proving. So let's do that. As we say, it's a workshop. It's not really a teaching moment. We'll just go through some possible scenarios that you can get in the examinations that you need to look at. All right, so far we have looked at when they are parallel. We look at how we find the length of the line. There's another part of it that I have not done, which is actually when we draw the triangular laws, but the time won't allow me to do that. Maybe next time around. Half A plus 1/3 B. And that is what AB is equal to. And BC, 2A plus 4 upon 3 b. And because it's a vector, we must never leave out these. Very important. And that shows that they are vectors. So you need to prove that there is a relationship between this and this. Now normally but I always tell students, whether you're doing transposing, algebra, whenever you get a fraction, you try and always, in a fractional situation, I always say get rid of the denominator by working it out to get rid of it. Whether you're going to find the LCM or find the common denominator, whatever. So I would attack this one first, because I want this to look like this, right? So let's see how we do that. So we could say, could find the LCM, let me work it out. What 3b, work it out regular way. LCM is what? Same is 3. Call it BC same way. Trying to make it easy, right? 1 into 3, so you're going to get what? 6a. 6a plus what? 3 plus what? 4b. Okay? So, bringing it, because this is still, we're working it to cross multiply, so you're going to get 3bc, right? 3bc is equal to 6a plus 4b. Okay, 6a plus 4b. But remember, you know, we want to say, oh, well, we can rewrite this to look like this. Okay? All right, let's see how further we can go. If we go to go any further, what we can do, we can divide this 2 by 2. Divide this 2 by 2. So if we divide this 2 by 2, divide that 2 by 2, so we get what? 3 upon 2 BC is equal to what? 3a plus 2b. Okay? All right? Now if you notice in the answer here, it's in terms of a, so we have to get, so let's see what happens over here. Let's see what happens over here, because the idea is that for us to, it has to resemble this. Okay? It has to resemble this. So let's get rid of the 3 from beside the a and see what happens. So we divide this side by 3, divide that side by 3. So it's 3 upon 2 BC. And when we divide this by 3, it's multiplying by 1/3. So if you multiply this by 3, you multiply by 1/3. So that multiply by 1/3. I mean, say if you multiply this, if you multiply 3 upon 2, if you multiply 3 upon 2, what are we going to get? We're going to get 3 upon 6, which is a half. All right? So we're going to get what? So we're going to get half BC is equal to 3a. Sorry, we'd have got rid of the 3. So that'll be a plus 6b. All right? A plus 6b. So let's go down a little further and see what happens now. Get rid of the 6 here. Get rid of the 6 here, what we do? Multiply this by 1 upon 6. Multiply this by 1 upon 6. So we end up with, but that's not what we want. That's not what we want. So the easiest thing for us to do then, based on what we are seeing here, instead of trying to convert this to this, then let us factorize out this then, because approaching that way, because that's what again, you can work it from here to here, or you can work it from here to here. Okay? So let's work it the other way. Let's work it from here to here. Can we factorize out? Can we factorize out this? Can we factorize out this? If we were to factorize out this with a half, factorize out this with 2 then. So we say 2 a. If you divide this by 2, you multiply by a half. If you multiply this by a half, you're going to get plus 2/3 b. Okay? If you divide this by 2, you divide this by 2, you divide this by 2. If you divide this by 2, you get a. Divided by 2 is the same thing as multiplying that by a half. Okay, so let's where we go from there. So if we get rid of the 3 there, what we do? Multiply this by 3, multiply this by 3. A times 3 is equal to 2 upon times 3 times 3b. Okay? So that's going to 2, 3a plus 2b. Let's start again, because some person might have been lost right based on what I've seen. Let's go again. Let's start again. To prove that it's collinear, students, we have to prove that this resembles this. Okay? We have to prove that this resembles this. Okay? How do we do that? We can find a factor of this to go into this, or we can find a factor of this to go into this. Okay, so let us examine them very closely. When we look at a half, what can you multiply by a half by to get 2? What can we multiply a half by to get 2? 4. Okay? So if we multiply a half, so in other words then, let us look at it technically. If we multiply by a half by 4 to get 2, then if we multiply by this by a half, we're going to get this. So technically speaking, what we are simply saying, students, is that BC is equal to 4 times half A plus 1/3 B. That's what we are saying. Because if you multiply this by 4, 4 times a half is what? 2A. And 4 times, will I give you this? So therefore, AB will be equal to 1/4 of BC. Okay, so somebody said to me, so where you get the 4? Let's examine it again. Can remember I said there's a relationship, you know. When we look at it, BC and AB, look, BC and AB. Look at this. A half and 2 here. When you divide 2 by a half, you get. And normally the factor that works for the first one also works for the second one. Okay? So the other way we're trying to break it down to the similar factor. So because this is the relationship, then A, then AB and C are collinear. I try to work it much easier because working it the other way was much longer. So that's what I do. I just look at the connection between basic mathematics. Let me say we can basic mathematics and show it. It's like I have 4 up there, so I have 2 down there. So. Right? So I said 2 into 4 go. So if 2 was here, let me just say 8 to that there, so. right? So if 8, 2 is there and 4 is there, right? That means that that 4 has to be there. So there's a mathematical relationship there. That's why I said we looked at the half, looked at these, a half and this, and automatically it works. If you notice, if you multiply this by 4, if you multiply this by 4, what you get? Look what you get, and see if you get back this. 4 times half A. What is 4 times half A? Right? 4 times a half is what? Not 2. Huh? What is 4 times a half? Not 2. Huh? Which is the 2A here. And it is 4 times 4.3 times 4. And you get back that. Okay? Because 4 times a half is 2, and 4 times 1/3 A is 4.3. Let me show it. Four times half A would have be 4 times a half A, which is equal to 2A. So the 2A here, 4 times 1/3B, all right? There's nothing here, so that like 4 ones 4, 4B upon 3, 4B upon 3. Get it back here, so. All right, so to prove collinear, all I need to prove that there's a mathematical relationship between the two pieces. In this case, AB is a quarter of this, right? And when you do that, you know, say it is collinear. So to prove collinear, all you need to do is to prove that any two pieces of the line, you just need to prove that any two pieces of the line have a relationship. Quickly, in closing, because the time is going. Right? This could be, for example, 2A, and this is 4A. Just to make sure for clarity. So it proves that there's a relationship between AB and BC. What's the relationship? AB would have 2A and 4B are 1. BC is 4A. So what would be the relationship? You know, so that AB would be equal to what? A half of BC. Why a half? Because this is 2 and this is 4. So 2 is a half of 4. Yeah. So therefore, once there's a mathematical connection, then once there's the mathematical connection, so therefore A, B, and C are collinear, or A, B, and C would be on a straight line. So I think we end this segment here. I don't know if there are any questions in the chat. You can ask the questions now. You can ask the questions now. If there are any questions in the chat. Huh? Yes. Yes, I can stop it now because presentation. Yes. It is being recorded, so you can always get a recording of the seminar when I get a chance to. That is not an issue. So that is the situation. Right, you can always go to the Jamaica Observer website and see the recording.
Just a little girl, but I have big dreams, and one day all my dreams are going to come true.
That's why I'm glad Mommy opened a Surgical Bank Star Savers account for me.
It's the best gift she could ever give me, because one day I won't be little anymore, and my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Surgical Bank Star Savers account today. just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today.
All right, so we're going to be having some questions because we're going to be giving away some things. And the first question we're going to ask is, on what day is the Jamaica Observer Online Study Center published? So on what day is our online study center published? So there are 7 days in the week. You can probably just choose a random day, you might get it correctly. Are we getting anything in the chat? You can also go to our website, www.jamaicaobserver.com, to have a look. All right, so Tanya Stewart said Tuesday, and that is correct. Or Jamaica Observer Online Study Center is published on Tuesdays. So that's Tanya Stewart. And we're making note of the persons who got the answers correct. The next question says, what is the minimum balance to open a Star Savers account? So if you're watching the advertisement before this, you'd have the answer. So what is the minimum balance to open a Star Savers account? if you have to quickly rewind the video to go and see what the answer is. No, it's not 5,000. Yes, it's 200. Thank you, Tamoya. So you were watching. So the answer is as little as $200 to open a Star Savers account. Question 3, very easy question. What is the name of the workshop? This workshop, what is the name? It was said at the starting of the stream. What is the name of the workshop? So the name of the workshop that we're currently at, what is the name? And we're looking for your answers in the chat. You can answer on Instagram or on the live stream or on Facebook as well. And remember, while you're answering, to subscribe to our YouTube channel, Observer Clips, and follow us on all social media platforms at Jamaica Observer. The easiest question, and we're not getting any answers. What is the name of the workshop that we're currently at? Close, but you're missing a key feature. Also close, but not correct. Not online CSEC. So that's close. So we'll take that one from Tia now. Tia Moya, my apologies. So we'll take the answer from Tia Moya. Our next question is also a very easy question. So the first person to answer, how many followers does the Jamaica Observer have online? On Instagram, sorry. How many followers does the Jamaica Observer have on Instagram? Just run over to our page quickly, and when you reach over there, follow us as well, so we can go up. That's correct. We have 546,000 followers on Instagram. And our last question it's a math question, so if you're listening, what is the term used when 3 points are on a straight line? What is the term that is used when 3 points are on a straight line? It's the last question that Mr. Hilton would have answered. The term used when 3 points are on a straight line. We can give them some options, Mr. Hill. So what are the options we're giving them? We're giving them linear, collinear, and and parallel. So out of those 3 options, linear, collinear, and parallel, what is the term that is used when 3 points are on a straight line? And Tonan got it correct. So it is collinear. When 3 points are on a straight line, the term is collinear. So thank you guys for answering all those questions. We have 5 winners. We'll get in contact with you to let you know how you can get your prizes. And we're now going to go to another ad from our sponsor, Sagicor, and then we'll have another hour of study session.
But I have big dreams, and one day all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me, because one day I won't be little anymore, and my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today. I am just a little...
Welcome back to the second session in the Jamaica Observer's lecture series, Mathematics. And for the second session, we're going to be looking at transformation geometry. And this is a topic that comes every year. Normally, it comes with you looking at a graph, and it asks, it either give you a triangle or a rectangle, and it asks you some specific questions. So what I'm going to be doing before I go into the intricacies of transformation geometry, I'm going to be giving you some general information, and what we're covering today, we're looking at translation, we're also looking at rotation, and we're also looking at reflection. We're not going to do any enlargement today. So the three of them, translation, rotation, reflection. So what I'm going to be doing, I'm going to be sharing my screen with you, and I'm going to be going through some notes with you to basically look at what are the properties of each of these things so that we can. So the first one, reflection. You say, what's a reflection? A reflection is a flip. The flip is performed over a reflection line, okay? And basically, over there are several reflection lines, right? Several reflection lines. We have reflection in the x-axis, we have reflection in the y-axis, we have reflection on the y equal x, and we have reflection in the line y equal x. So what I'm going to do, a little demonstration of, let us look at the properties of a reflection. For the reflection, the object and the image remain the same in terms of size. There is no change in the size. Or what happens, it flips, right? So I'm going to be doing a quick demonstration with you to demonstrate that with you, to make you see what is happening there so that you understand where I'm coming from. So I'm going to be going on a graph paper now, and I will be demonstrating to you. And there we see a triangle, and let me draw another triangle just to use a different triangle to demonstrate my thing. So that, all right, okay, that's a triangle here, and as we say, reflecting it over a line, and we have different lines that we can reflect it over. We can reflect it over the x-axis. We can reflect it over the y-axis. I'm going to take these two triangles out of the way. Move these triangles to that side. So let me show you what it would look like if I were to reflect it over the y-axis. So I'm going to reflect it over the y-axis and let you see what it looks like. So, okay, I would have noticed what happens there. That was the original shape, and it's reflected over the y-axis. So if you notice that there's a word that I did not use, and I deliberately did not use that word. I just wanted to make you see what a reflection looks like. And the word that I did not use was the word mirror line, right? Mirror line. So in other words, for you to have a reflection taking place, you have to have a mirror line. And in this case, the mirror line would have been the y-axis. In other words, this axis here, that would have been, this line here would have been the mirror line. Now, let us look at what it would look like if we reflect it over the x-axis. So the x-axis, this will be the x-axis. The x-axis. This is the x-axis. Let us see what it would look like if we reflected. I'm going to reflect the original thing over the x-axis. Okay? The x-axis. So let us look at what it would look like. So this is the object. This is the object, and I'm using the original object here, and I'm going to reflect it over the x-axis. All right? I notice what happens. So what we have two shapes. We have one reflected over the x-axis and one reflected over the y-axis. What you would have observed is that where the mirror line is, the object and the image equal distance away on the mirror line, equal distance away. let me just use red instead of, green. Sorry about that. Let's go back. Right. So this is the mirror line, as we say. And the points are equal distance away from the mirror line. Right. There's no change in the shape of the object. It flips. It flips. No, but for the exam, here's the trick with the exams now. There are several, and let me go back to the formula sheet for you. Let us see what's happening there. In the exam, there are several reflections you will get. Right? So if you notice, these are some examples that are the formulas that are there over the x-axis. That is the formula that is there. You can write it down. Over the y-axis, over y equal x over y equal minus x. Now there are two missing. Well, you have y equal x is missing. I want to see y equal minus x is missing along the x and along the y. So I'm going to show you how you do that, but the trick is in the exams. Normally, what is happening now? CSEC is not necessarily asking you to work it out physically, right? They are expected for you to use the graph paper that is there to estimate where the image would fall. Let me explain what I mean by that. All right, so let me go through all of the different lines with you, and then we look at the demonstration. And this is reflection. I'll soon be looking at rotation, and I'll soon be looking at translation. So let me explain what I mean by that. So let me go back to the graph quickly. Let me go back to the graph. All right, let me go back to the graph. Okay. All right. So let me start originally. Let me start. All right. So let me start with this fresh graph paper, students. And what I'm going to do, I'm going to demonstrate to you all of the different mirror lines that you will get in the CSEC examination. Very important. Okay. Now, I just did 2 a while ago with you. I did reflection in the x-axis and reflection in the y-axis. But what I'm going to do, I'm going to highlight on the paper where the mirror lines are, right? Highlight on the paper where the mirror lines are, and then I'm going to do a quick demonstration of what the reflection would look like, and then ask you the questions that CSEC will ask you, right? So let me start off with a question like this. So let us say we have, let me just put on a question on a triangle. So in the exam, they would have given you a triangle on the paper. So let me just put on a triangle on the paper. Put on a triangle on the paper. So right, so that's the triangle. So the question could say, this triangle is reflected in the x-axis, then reflected in the y-axis. So let me do that quickly. I'm going to reflect, so I'm going to reflect it in the x-axis. Let me make sure that it is correct. So that I'll move off a little bit. All right. So I'm going to reflect it in the x-axis, then I'm going to reflect it in the y-axis. And a question like this came on the 2019 June paper. I'm trying to remember the exact question, but it is framed just like this. So it's reflected in the x-axis, so I'm going to reflect it in the x-axis first. And then I'm going to reflect it in the y-axis. All right, good. So this is the question you'll get. And then here what CSEC is going to ask you now. They're going to ask you, could you describe a transformation that, let us say this is the original, this is the original. This is the original. I have image 1. I have image 2. Good. So they could ask you 2 questions. Question number 1. What is the single transformation that maps the final image back to the object? Right, the final image back to the object. Now, if you should look at it, it will look like right? A reflection in the line, this line, and this line is y equal minus x, because that is the mirror line for y equal minus x, and that is the mirror line for y equal x. Well, I given too much information one time, so let me go back a little bit, because that's about wow. So we say reflection in the x-axis. The first one was a reflection in the x-axis, then the second one was a reflection in the y-axis. And the question I asked you was, what is the transformation that can map the final image back to the original object? And when we say it will appear to be a reflection in the line y equal x, right? And then of course the CSEC will ask you to write the matrix for it. And the matrix for that is 0, minus 1, minus 1, 0, which means then that you have to study all of the identities for all of the, let me just, that fell off the paper a little bit, let me just make it a little smaller that you can see it. Sorry about that. So 0, minus 1, minus 1, 0, right? So that is the transformation for reflection in the line y equal x. So normally, they don't normally ask you to describe a reflection. They just need you to know what a reflection looks like, right? And then they normally ask you to, like, what maps back the image back to the original object, right? And in cases like this, sometimes they may give you a reflection and a translation, which is referred to as a Grail reflection. But normally, if you get the trick to that now. There's a little trick here which I'm going to point out to you. If you get a reflection and then a translation, it is a Grail reflection. But they could have given a similar question like this, and the image ends up exactly where it is right now, and they ask you to describe it. Notice in this case, it is two reflections, so you can't call it a Grail reflection because there was no translation here. We're going to go to translation when we finish. Because translation means that the object just move, right? There's no, what's it now? There's no, it just move, like a mouse on a computer. It just move. It don't turn or anything like that, right? So, what do you need to know about translation? I mean, not translation, reflection. Let me go back to the notes quickly, that you can see it. Go back to the notes. Let's go back to the notes quickly. Translation. What do you need to know? You need to, let's go back to the notes quickly. Okay, so it's a flip. The flip is performed over a mirror line. The lines of symmetry are examples of a mirror line. Reflections are isometric, but do not preserve orientation. So let me explain those fancy words. And there's a word I'm going to introduce, which I don't want nobody get too excited about, and the word is erect. Erect means upright. I am upright now, so it means it don't flip, don't turn upside down. So under reflection, for reflection, the orientation of the shape is not preserved. That means that it can turn, can drop, right? And if you looked at the reflections that I showed you earlier on, all of them would have, all this is a change in the position where the object is. So that's that for translation, because we want to look at some parts, we want to look at some questions when we finish, so I can't spend a lot of time on one. So I'm going to go to the other one now. We're going to go to the translation. Translation, quickly. What's a translation? Sorry about that. What's a translation? All that happens is that the object moves. Let's go down. Translation. Translation, a shift or a slide. Okay? Translations can be occurred by performing composite reflections over a parallel line. Okay? Translations are isometric. That means that the orientation is preserved. What do I mean by orientation? this shape doesn't topple. It remains, all right, if I'm translating, I walk. So I remain upright same way. So it's always upright, facing the same direction. So the isometry is not, it is preserved, meaning that the object doesn't turn around. It remains in the same direction. That's what that means by the isometry is preserved. So let me do some demonstration on the graph paper to make you see what translation looks like. So let me go back to my graph. Let me go back to my graph. Go back to my graph paper. Okay. All right, so let me go back to my graph paper. Let's look at that shape. And we have to translate it. Is it normally translated by a vector? So let us look at this question. So I'm going to do it both theoretically, meaning if you got in the exam, how they approach it. So let us say we have, this is A, this is B, and that is C. And we're going to translate it by the vector minus 2, minus 2, minus 2, minus 2, minus 2, minus 2. So we're going to translate it by minus 2, minus 2. And the general formula is for translation, object plus translation equal to image. So you add. All right, let me fix that up a little better. I think you're not seeing it, so let me fix that up a little better. Sorry about that. Let me fix it up a little better. The translation is minus 2, minus 2. And normally, formula object plus translation equal to image. So what you do, you add each of the points. So for the first one, A, based on this, A is 3, A is 3, 2. B is 6, 2. And C is 6, 4. And we're going to translate all of them. So we're going to translate A. So we're going to translate A, which is 3, 2. Let me just do that quick. So it's A. So it's A, B, C. So A is that equal to 3, 2 plus minus 2, minus 2, and that will give me 1, 0. And that would be A prime. That's A prime, okay? B prime, I'm going to add 6, 2 plus minus 2, minus 2, and I'm going to get 4, 0, and that's B prime. I'm going to write all the things that I'm finished. That's B prime, and C prime would be C is what, 6, 4 plus what, minus 2, minus 2, and we get what, 4, 2. 4, 2. You're not seeing that, so let me just move it and put it up top that everybody can see it. A equal 3, 2 plus minus 2, minus 2, and we get A prime, which is 1, 0. Then B, we get 6, 2 plus minus 2, minus 2, and you get B prime, which is 4, 0, and C prime, which is 6, 4, okay, plus minus 2, minus 2, and we get 4, 2. Let me just erase this. Too much space, get some more space. Equal to C prime, which is what? C prime is what? 4, 2. So let us do it on the graph paper and see what happens. So we're going to translate it, and the translation is 2, 2. So for me now, let me get the translation, back to that. Let me get the translation name, vector, it's a vector. Vector is, so a second, let me get the vector. Vector is 2, 2. So 2, 2 looks something like this. Right. That's 2, 2. So let's translate it now. So we're going to translate it by the vector 2, 2. So we're going to translate it. Translate by the vector. Select the shape. Select the vector. Sorry, let me go back. Sorry. All right, let me just translate it quickly. Translate by a vector. Let me just draw the vector again. Oh. So let's put it there. Let's put it in as it is. When a equal 1, y equals 0. When x equal 1, y equals 0, so it would have been right here. X equal 1, y equals 0. Let me put it in. Next one, when x equal 4, y equals 0. Right there. When x equal 4, y equal 2. Right there. So if you have to draw, put in the line segment, draw the line segment. Sorry about that. I'm going to draw the line segment. So the line segment would have been there. And that would be, if you notice, the object is in brown and the image is in black. Right? So that would have been the translation. Right? So if you notice, the object still is pointed in the same direction. Right? All it do, it moves. Right? So that's what a translation looks like. All right. Now, for CSEC, they put translation with something. They don't just give you by itself. So they can give it with reflection, or they can give it with rotation. But the plus is that normally what is happening now, that they are drawing so guess what they can ask you? Well, you work it out already, you know. But what they could have asked is to write down the coordinates of the image. We'd have worked it out already, so it is there. So they'd have asked you to work out the coordinates for the image, which we'll have done. They can give you the exam where they get the object and the image and ask. They can give you this situation and ask you to describe this transformation, what it is. And you'd have been able to look at it and say, it is a translation. Why? The isometry is preserved, meaning that it is still upright, it is facing the same direction, the image and object facing the same direction, there's no flip, and the size is preserved, meaning that none is larger than the other. Both of them have the same size. So there is no change in the size of the image and the object. Oh, what happens? It moves, right? So that is what CSEC is likely to give to you in terms of exam type situation. Because this is a seminar and we look at the possible situations that you could get in exams. I don't know if anybody has any Any questions to that before we move on to rotation? And then if anybody have any questions to type in the chat, re-rotation, right? So that's what a translation object plus translation equal image. However, hear this now, students. They could give you an object and an image and ask to find a translation. So I'm going to show you how that is done quickly. I'm going to show you how that is done. But they can get the object and the image and ask you to find the translation. So I don't want you to go into the exam and get that type of surprise. All right? How would they do that? Very easy. Guess what I did a while ago? I gave you an original object. My board is stubborn, it doesn't want to. Yeah, how could I give you that in the exam? It's very simple. What I did a while ago was I gave you an object and I gave you the translation and asked you to find the image. Here's what they could do in the exam. They give you the object and the image, drawn on the graph paper, and asked to find the translation. So how would you do that? So all you do, you just choose 1 point on the object and 1 point on the image. So if the formula is object plus image, if the formula is object plus image, formula, if object plus image plus translation is equal to the image, then if we're going to find the translation is equal to image minus the object, right? So on the image, so this is like, let me go back to the labeling. So it's like A prime, B prime, C prime. So what is A prime equal? A prime is what? A prime is 1, 0. And what is A? A was what? 3, 2. So if object plus translation is equal to the image, then the translation is equal to image minus the object. So what is the image equal to? The image equal what? 1, 0. The object was what? 3. All right? So what was the translation? Let's translate 1 minus that, minus 2. And of course, students, that is what we had used for the original translation. So I'm just saying that instead of asking you to draw the image, they can get the object and the image and ask you to find it. So that's that for translation. Let's go back to the notes again, and then we look at rotation. What does the note say? What does the note say? The note says that what a translation is, just a second. The note says that a translation, slide or shift, translation can be achieved by performing 2 composite reflections over parallel lines. Okay? 2 reflections can give you a translation based on what this is saying. Okay. Okay, let me go back to all right. Remember that we said that transformation is when the object moves. The object moves. When the object moves, we're looking at 3 different ways it can move. Okay? There are 3 different ways it can move. What are the 3 ways it can move? So I'm going to do it on the board and show you what happens quickly, that you can see it a little easier. All right, transformation geometry means the change in the position of a shape. geometry deal with shapes. So it can be triangles, it can be rectangles, etc. Right? All right, so better say this is your graph paper. Okay? Graph paper. Right? There are different types of transformation that can take place. The first transformation we looked at was reflection. Reflection meaning that this is here, goes over there. That's called a reflection. And this would be the mirror line. Okay? There are different types of reflection. We have this is the x-axis, y-axis. This one would have been a reflection over the x-axis. Okay? Reflection over the x-axis. Right? We can also have reflection of that. Say if the object is, so this is like a mirror line. A reflection, and you look into the mirror, this is like the mirror line. So you look in here and it comes over here. Okay? If this is here, it comes over here. Alright? Let me use a box because I don't want the shapes to be out. They're very basic. So if this is here, it comes here, if it's a reflection over this line. If this is here, it comes over here. That's reflection. Okay? So reflection means that it flips. It flips over them, it flips. Alright? It flips over. So if this is here, it flips over there. If this is there, it flips over here. It moves. So that type of movement, because it's transformation geometry, so it's changed at the position. And this one is a reflection. But you have different types. We say we have reflection, we have rotation, and we have translation. The first one we did was reflection, where if it is here and it reflects, it comes over here. If it's here and it reflects, it comes over here. All right, that's the first type of. And we said there are different. We looked at the formulas. I gave you the formulas. You have. So this is reflection in the x-axis, reflection in the y-axis. I have this one. You have this axis there. This axis there meaning that if it is here, it comes over here. This line is called reflection in the line y equal minus x, and this one is reflection in the line y equal x. So that means if it is here, it comes over here. So it moves. Okay? We looked at translation. For translation, it's the same, is a movement again, but it's different. For this movement, all what happens for this movement. For this movement, the shape is here. If they're here so. And it translates it go here so, for argument's sake. Alright? In all of them, the object and the image, with except that for this one, it faces the same, we all have it move. Up like a mouse, like the cursor on a mouse, all of the up, it moves. It doesn't spin. So translation, and for the translation, for you to know, this is the object, that's the image. The formula to work it out, object plus the translation is equal to the image. So I'm saying to you, in the examinations, most of the time they normally draw, it's on graph paper already. So for argument's sake, they'll give you this on the graph paper. And they say either you're going to translate it or either you're going to reflect it. So what they want you to do is to know where it's going to be. If it's a translation, they're going to give you the translation. Okay? If it's a reflection, then there are different reflections that you'll check in your notes. You have reflection in the x-axis, reflection in the y-axis, several of them. Going back up to the notes, reflection in the x-axis, reflection in the y-axis, reflection, and the formulas are there. So if it's reflection in the x-axis, the y value changes. If reflection in the y-axis, the x value changes. All right? For y equal x, it switches around, and for y equal minus x, x and y switch around. All right? So as I say, you just need to use these as formulas to work out the thing. All right? I don't know if that clarified anything. If you get any clarification, send it back in the chat that I can. Any clarification there? Okay? All right, so the last one I'm going to look at now is the last movement is rotation. So rotation. So for rotation, rotation is a turn. So it turns. around something. It turns around something. All right? So what I'm going to do, before I actually go through, I'm going to make you see what's happening, and then I explain. So I'm going to show you a rotation, and then I'm going to show you the rotation. All right? So for the rotation, right? Just a minute. Rotation. All right, let us look at this one. This one, all right? That's the rotation. And it's rotating around something which is the center of rotation. Okay? And if I'm going to move the center of rotation, I'll show you some. Watch here. Center of rotation, I move it. If I put it there, so it rotates around that point. Same way, center of rotation. Right? Put it back where it normally goes, which is right here. Right? Rotate. So what is rotation? Rotation is when a shape rotates around a central point. Right? Like a circle. It follows the path of what a circle would follow. So and I want to use this as the, so in other words, it's that the shape, it rotates. If this is the center of rotation, and it's going to rotate, I'm say it's going to go around this. Okay? That's what it means, rotation. Like the shape I showed you a while ago. So a rotation in CSEC means that the shape goes in a circular path around a central point. It goes in a circular path around a central point. Just like what I'm showing you, just like what you see there on it. You are seeing it on the screen? I don't know if you are seeing it on the screen. Yes. It's like what you are seeing on the screen there. So the question is now, so let me give the note. I'm going to look at the little notes that you should have, and then look at what CSEC requires of you. Right? What CSEC requires of you. So let's look at the notes. The notes basically says that, just a second, rotation. A rotation is a turn. Okay? Rotation can be achieved by performing, let's load that for the time being. Rotations, let's go down to the, all right. What does CSEC require you to know? There are three things for rotation, right? The direction of the rotation, whether it's clockwise or anti-clockwise. The angle of the rotation, that's in the degrees, and the center of the rotation. So there are three things CSEC requires you to do. Let me see if I can explain what that means in a nutshell. Let us say you have a point there and a point there. So, all right. So, what do you need to know? What is it? What direction of the rotation? Is it clockwise or anti-clockwise? But there's a little trick. There's a little mix-up here. I don't want to call it mix-up. Listen to this now. Clockwise rotation is negative. Anti-clockwise rotation is positive. So try to remember that. So whether the rotation is clockwise or anti-clockwise, that's the first thing. So clockwise will be going in the direction of the clock, anti-clockwise going in the opposite direction. The other one is the center of the rotation. What is it rotating around? And the final thing is the angle of the rotation. So this is, call this 1. Call this 2, call this 3. Angle of the rotation. Angle of the rotation. So let's go again. So let us say this was A, and it's A prime there. All right, so basically, what are the three things here? Right? Center of rotation. This angle of rotation. And this one, and the direction. Well, it's going this way. It's going that way. So it's the direction of rotation. So in the exam, when they ask you to describe the rotation, when they ask you to describe the rotation, there are three things you're expected to describe. Center of rotation. What is it? Where is it rotating about? Right? You have life much easier now, because back in my time, the center of rotation could be anywhere. Now, they tend to just make it remain at the origin. So life is much easier for you. All right? Back in the days, they put it anywhere, now you have to find it. You have some big formulas that you use and find it. Center of rotation map onto itself, find the vector that maps it on back and all of that. Anyway, you don't need to worry about that. The direction of the rotation, either clockwise or anti-clockwise, which is very important, right? And the angle of rotation. I'm just going to put in a number here. It could be 90 degrees. So if they ask you to describe the rotation, if they ask you to describe the rotation, if one of these missing, you're not going to get the full marks on the paper. All three of them must be there. All three of them must be there, because if all three of them are not there, then you will not be fully describing. So let me go back to the graph. All right, let me go back to the graph. All right, now, so we have three. Let me see if I can extend this, move this a little bit. Dot. All right, let me see if I can move this. Dot. Dot. All right. If you notice, what I have here is the center of rotation. When I move the center of rotation, after the image moves, because at the end of the day, right? Let me see if I can make the screen a little smaller for you. No matter still. All right, so it rotates about the button, the center of rotation. So, all right, let me see if I can. All right, that is it. Let us say that was the original shape in the position that it is in. So let me do something. This is 90. Oops. So I can't get the 90 degrees. Sorry. That's okay. Let's look at that. Okay. So we have the object. The object is where the ABC, and the image is where it is. So the question is now, on the paper, let us say you got this paper in the examination. So they're going to ask you. So they draw the object and the image on the paper, and they ask you to describe this said rotation that has taken place here. So let me label it. So this is the object. One where the ABC is the object and the other one is the image. Okay, so the question is now, how would you be able? So what I'm going to do, I'm going to trace the points again and make you see what is happening. I'm going to trace the points again. Let's go back. Okay? Look at where B is. Just look at where B is. Look at where B is. Okay, look at where B is. Look at where B is. So in other words, this would be B prime, right here. Okay. So the question is now, and that is 90 degrees. So the question is now, how would you be able to, if in the exam, how would you be able to find the angle of rotation? All right, they ask you to describe this transform, this rotation. They ask you to describe it. So here in the exam, how will you describe it? So the first thing that you will do, you draw a line. Look for 2 points, a point on the object and a point on the image. So let me do that. So if I can draw a point on the object, so if I can draw dot, line segment. All right, so, okay. I'm going to do the same thing again. Same thing again, line segment. Right there. So therefore, students, and the angle, this will be the angle, right there. So this, to describe this shape, so you get this in the exam. This is what you get. So they ask you now to describe this rotation. Okay, so you would say it is if you note it went this way. It went this way. So that is a anti-clockwise rotation. It went the other way. And the center of rotation would be 0, 0, the origin. And based on the angle, based on where the lines are drawn there, it would be a 90 degrees. So it would be a 90 degrees anti-clockwise rotation about the origin. So let me go through that again. You're in the exam and you got this shape. Object, image. First one is the object, second one is the image. And you're asked to describe this rotation. Okay? And I said there are 3 things you do when you're describing a rotation. What are the 3 things? Center of rotation, the direction of the rotation, angle of the rotation. Okay? The direction of the rotation is whether it's going clockwise or anti-clockwise. The center of rotation is the point at which everything is rotating around. And the angle of rotation is the angle that the object would turn through. So the question is, how would you describe this? And I just explained to you that first, you'd have to look for 2 corresponding, a point on the object. So we look for B. That's why I said, look where B is, a point on the object and a point on the image. So we looked at B. B was right here, right? And it go right here, so. Right? So you draw a line from the, all right. Everybody following what I'm doing, just getting a feedback. Everybody's following what I'm doing. Just type in the chat if you are following what I'm doing. All right, okay? If you are following, okay, yes. So, so you're asked, so this is what you're expected to do. All you would simply do is draw a point, put a point on the object, corresponding point on the image, measure the angle, because you'd have expected to have your protractors in the exam. And then you'd write all of the 3 things. So what you would write is anti-clockwise rotation of 90 degrees about the origin. That's what you would write. Okay? Anti-clockwise rotation. Or you could write rotation of 90 degrees above the origin. Why 90 degrees? Because anti-clockwise rotation is positive. So you could write it like that. So you could say a rotation of 90 degrees above the origin. Once we write the 90 degrees positive, we automatically know say it is anti-clockwise. So 2 ways, so you could write it like that too in the examinations. I don't know if, all right, so what we're going to do, we're going to look at the observer paper and see what is happening there. There are no further questions. We're going to look at the paper and see if there are any questions there that we would like to answer. All right, so we're going to go straight down to the questions. All right, so let's, okay, all right. Okay, so let us look at, then if you are seeing it, let me see if I can blow it up a little bit more, that you can see it. All right. Then if you are seeing the first one there, it says you should the transform rotate of 90 degrees above the origin. What does the new design look like? Now, let us go back to the cheat sheet for, okay. So if you notice that we have some quick ways we can work out the, because normally we use the matrix, but some people say the matrix is the old way. So we have some easy way we can use to work it out. Clockwise rotation of 90 degrees is the same thing, and let me just do that quickly. Okay. This is the anti-clockwise rotation. All right, I'm moving from here to here. Moving from there to there, which is 90 degrees. So I can take the shorter route of 90, I can go the longer, because remember that a revolution is 260 degrees. So I can take the shorter route of 90, which is anti-clockwise of 90, or I can go the longer route of clockwise to 170. So what they are simply saying is that 90 to 70, right? A clockwise degree of one is the opposite of the other, right? A clockwise of 970 is anti-clockwise this, right? So that's where it goes. Because anyway, you take it. 180 would be, it don't matter. Because if you are here and you go 180 at the same, if you go 180 clockwise or you go 180 anti-clockwise, it's the same place you would go. So let us look at the cheat sheet and look at some of the formulas. A clockwise of 90 degrees, counterclockwise or anti-clockwise, let's look at them quickly. Write them down. That while we are doing them, we can see. All right, so we have AC 90, and for AC 90, anti-clockwise 90, you flip, if you change X, Y, change it to minus YX. Okay, 180 is the same thing. That's why I don't even trouble 180, because 180, it does switch out, it does a sign change. Right? Okay, X and Y changes. And for 270, right, Y change and X changes. And that is what? Equal to minus YX. Okay, so question now. Let us go back. So what I'm going to be doing, I'm not going to be actually working out all of them. I'll just be showing you how you work it out. So let us look at the first one. First. So anti-clockwise of 90 degrees, this. And anti-clockwise of 90 degrees is the same thing as a clockwise of 270. This doesn't make a difference. Okay? Anti-clockwise of 180 is the same thing as a clockwise of 180. right? And anti-clockwise of 270 is the same thing as the clockwise of 90. So, you know, it's easy to remember from that side. So that is why I do it like this. So let's go back to the worksheet. First, the worksheet. All right, the worksheet. All right, so the worksheet is go back to the worksheet. Right, so that's the question there. So the question is basically asking us to work out what. So let me snip it and make it a little bigger that you can see it. Change it to take it off of the graph. Straight block. Sorry. All right, so let me see if I can make it a little wider, that everybody can see it. Okay. All right, so I don't know if, so let us look at the, it is not labeled properly, so let me label it so that we can label it properly. So let us call this this A, B, C. So, all right, so let us call that A, B, C. So right now the coordinates are A, B, C, A, B, C. So what's the coordinate for A? Coordinate for A would be what? -5, -1. By looking at it, I don't know if you can see it very well. Switch it back and look. I don't know if you can see it very well. -5, -1. Are we good with that? Okay. Okay, let's go. Coordinate for B. Coordinate for B is what? -5, -4. And the coordinate for C is what? Coordinate for C is what? -1, -4. And they're asking us to do what? Go back to the question. What are they asking us to do? They're asking us to rotate what? 90 degrees clockwise about the origin. So we know so 90 degrees clockwise is the same thing as -270 degrees anti-clockwise. Everybody get that? It asks you the question, asks it. We're going to by rotating this triangle 90 degrees clockwise about the origin. I want to say 90 degrees clockwise is the same thing as 270 degrees anti-clockwise. All right? 270 degrees anti-clockwise. So this is what we're going to use. This one. Because 270 degrees anti-clockwise is the same thing as 90 degrees clockwise. So so this is what we're going to do. Use this formula here. Right? So we switch the x and the y and change the sign of the y. So we switch the x and the y. So let's do that first. Switch the x and the y. Switch x and the y. So this would be -1, -5, -4, -5, -4, -1. Just switch x and the y and then you change the value of the y that you switch. So if you know the y is, so if you notice the y multiplied by a negative. So here so, we have positive. Negative and negative give positive. Negative and negative give you positive. And that would be the answer when you work it out. So you can write on the answer there. Let's go again. The question asks us to what? Rotate 90 degrees. The shape that is there, go back to the shape for me, please. The shape that is there for us to rotate it what? Clockwise 90 degrees. And I'm saying clockwise 90 degrees is the same thing as anti-clockwise of 270 degrees. because everything must add up to 360 degrees. Let me go back through that part for clarification, because some person might have challenge with that 90 and 270 degrees. So let me go through that quickly for you again to make you understand what is happening there. All right. So let me go through that one more time with you, so that people get the clarity there. Okay. You can let us say you are there. Okay? And you want to reach here. This is 90 degrees. Okay? So I can go 90 degrees or I can go the longer route. Right? I can go what is the longer route? The longer route is to go clockwise, but it would be 90, 180, 270. Okay? So therefore I can go the shorter route 90, anti-clockwise degree 90, or I can go clockwise 270, which is the longer route. So that's why both of them work out to be the same thing. So in other words, 90 degrees anti-clockwise. This is the example, like 90 degrees anti-clockwise. I reach the same place as if I had gone 270 degrees clockwise. Right? So that is why I said that to find the flip of this is subtracted from 360. 90 from 360 is 270. 180 from 360 is 180. 270 is 90. So therefore, anti-clockwise degree 90, clockwise 270. Anti-clockwise 180, clockwise 180. This doesn't really make a difference. Always change. Anti-clockwise 270, clockwise 90. Are there any questions with that one? Any questions there? Before we move on to the next question. All right, let's move down. All right, so let's move down to the next question. Okay. Next question. Sorry about that. All right. Okay, let's look at these. All right, let's look at these. So the questions that they'll be asking is, for each of these, what type of transformation take place? All right, what type of transformation take place? Let us look at A. That one is a giveaway, because that one it just moved down. So obviously it is a translation. So it just move down. And move down. Okay, that's A. So A would be a translation. All right, A would be a translation. I don't want to erase that. So A would be a translation. I'm going to write T for translation. All right, let us look at C. C. Not going any order. C. What would C be? Let me go up a little bit more, because maybe we can't see C. Yes. That's this one here. That one. C. That would be A. What is it, A? Could somebody type the answer what they think C is? Somebody type what C is. What C would be? Translation, rotation, or reflection? Somebody type in the chat what they think C would be. Nobody typing in the chat? C? What C would be? All right, C would be a reflection. Yeah, who was that? Tanya, thank you. C is a reflection, right? Because the mirror, you can see that this is the mirror line is there. That's the mirror line, right? And it reflects. All right, let's go up to the other one there. Okay, let's look at B. B would be more look like a what? B will look more like a rotation. B will look like a rotation. What about D? It looks like a reflection, but it's actually a rotation. All right, let's go down. Okay, let us look at this. Let's look at the shape. It says, I don't know if you are seeing it very well. By looking at that, we realize that it would be a, what would that be? It would be a reflection. But the question is asking us which transformation could be used to show that A and B are congruent? A is congruent to figure B. Now what congruent means equal in every respect. It's like a twin of it. That's what congruent means. When we are doing geometry, we do similar triangles and congruent triangles, right? All congruent triangles are similar, but not all similar triangles are congruent. All it means is that the size, they have the same shape, but it has the same shape, but it don't necessarily have the same size. The question is, how can you prove that they are congruent? It's a multiply each x and y by -1. Rotate 90 degrees above the origin. Okay. For you to prove that it is congruent, you'd have to use some sort of movement to know that. All right, because there won't be any change in the size of the shape. All right. Let's go down. All right, so, okay. As I said, this is a brief workshop in terms of stuff that we had to cover for the syllabus. What are some of the things that we need to know as far as transformation geometry is concerned? If they give you combined transformations, make sure that you, well, I didn't do enlargement because enlargement is sort of straightforward. The only good thing I squeeze in with enlargement, just before I do the summary, the only good thing I squeeze in, are there any questions with rotation before we move on to, I just want to squeeze in a little on enlargement, just a little, nothing significant. Are we okay with rotation? Okay, so for enlargement, what they could ask you to do, they could ask you to find the scale factor. Because for enlargement, all what happens with enlargement is that one shape, they give you two shapes. Two shapes. Don't know which one they're going to give you first. They can't give you this one first or that one first. So don't know. Because I don't know what they might be testing. If, as I said, this is A, this is A prime, this is B, that is B prime, C, C prime, right? Obviously, this is an enlargement. But as I say, I have to be careful, right? Because an enlargement could also mean that you have to be careful with that. It sounds like an enlargement. That is why they use the word dilation to some extent, because there's an increase or decrease. Because if they give you this as an object, and then this as the image, that's not a real enlargement there. So you have to be careful when you use the word enlargement, because every time you multiply, you don't increase, you know. Because if you multiply by a fraction, you decrease. So you have to be careful there, so again. Right? If multiplying by a half and multiplying by a 2 are two different outcomes. So we have to be careful. But if in the exam they ask you to find the scale factor means how much the object increase to get the image. Then to do that, you divide the image by the object. So if I'm aside, so that'll be, for example, A prime, B prime over AB for it to equal to the scale factor. Right? And enlargement funny too, because enlargement don't mean that the object and the image is not all erect, because if the scale factor is a negative number, then it flips and goes on the other side too. So we have to be careful with that as well. Not sure CSEC going to give you that. Not taking a chance. If they ask you to find the center of enlargement, you connect all the object points. That. Let me just draw it realistically, because I don't want to spoil it like how CSEC spoil it. You connect the object points and the corresponding image points, and anywhere all three of them meet, that is the center of enlargement. So could draw that. All three of them supposed to meet at a point. Right? And this is saying somewhere out there. So we all let me erase this, make you see it a little better. Right. Let's go again. How do we find the center of enlargement? We find the image point and the object point, and we connect them all, three of them together. And where they meet, that will be the center of enlargement. So you have two things where you might have involve center of in exam. For rotation, it's center of rotation. For enlargement, it's center of enlargement, right? And they're not going to give the hard one, but the center of enlargement can be found anywhere. Just that you have to just connect all of the object points and image points together, and we all three of them connect. That would be the center of. I don't know if there are any questions for persons that can ask me to go over before we do the final summary. I don't know if there are any persons who want check in the chat. If you have a question to ask in the chat, please do so now. Any questions in the chat? Nobody? Okay, so let me just go back through this quickly. The quick summary of the rotation, transformation. What is transformation geometry? Transformation geometry is a change in the position or the shape of a geometric shape. Position or shape. Well, that's a change in the shape, means the size of the shape. Enlargement is very easy, but the other two can be a little bit challenging. That's the rotation, the translation, and the reflection. You need to know the identities, which you need to know. And the cheat sheet I gave you some quick ways you can use as reference. For reflection, you can use those. What does a reflection look like? Let me go back through the thing again. What does a reflection look like? What does a reflection look like? Reflection, if that is the object, and it reflects, it goes over the x-axis, the axis that is reflected over. So let me reflect this again and show you. Right, that's a reflection over the y-axis. Not the y-axis, x-axis. So that's a reflection over the x-axis. Let me show you a reflection over the y-axis. That's a reflection over the y-axis. All right. Let me show you a reflection in the line y equal x. Reflection in the line y equal x. First, I have to draw the line y equal x because it's not here. So let me draw the line y equal x. Draw the line y equal x. Draw a line. All right, line y equal x. So I'm going to use this one here to reflect over the line y equal x. Y equal x when x equal 4, y equal x. And x equal 8, y equal 8. Right, that's the line. And that line will be y equal x. And then if I'm going to reflect this over the line there, let me just move this. Okay, so reflect it over that line, let you see it, what it looks like. Okay, so this would be it, and this is where it was. So that's what a reflection looks like. Okay, translation. So I can show what a translation looks like. Translation. That's the translation that is there. So we can draw a vector, make you see another translation. Translate by the vector. I'm going to make this be minus 4, 3. Minus 4. Get the vector minus 4, 3. Let me see if I can get the vector. I have to draw the vector first. Minus 4, 3. 2, 2, 6. That's minus 4, 3. Minus 4, minus 3. Okay. And let me translate it by that. Translate by the vector. Select the shape. Translate. That's it. See there it moves. Okay. So if you realize that it moves, right? That what it moves to, right? Moves to that position. That's a translation. Notice the object and the image pointed in the same direction. Okay. For rotation. For rotation, I think we have one with a rotation. Let me see if I can do the final one with the rotation. In the meantime, if you have any questions to ask, you can type it in the chat. Okay. Okay. I think this is one with the rotation. Yeah, that's one with the center of rotation, right? And after the center of rotation, of course, would be right here. That's the center of rotation. Okay, and I say that if they give you that in the exam, and they ask you to describe the rotation, let me give an example. Again, undo that. All right. Let me do the 270 degrees. 270 degrees. Let me do 270 degrees. 270 degrees. All right, that's 270 there. Of course, 270. The one on the outside. Let's make sure. All right, that's. Look where B is. That's where B is. B is the one on the pointing to the front. All right. B is the one pointing to the front. That's 270. Then you draw a line from this to the center of rotation. Sorry. Draw a line. If you were asked to describe this rotation, you draw a line from the object to the center of rotation, image, and then the corresponding point on the object. Right? And this will be the angle. So you can go either that way, okay, or you can go the longer way. So it would have been anti-clockwise degrees of 270, or or clockwise degree of 90, as you'd have seen it. And the center of rotation is 0, 0, or the origin. All right? Then if there are any further questions you need to ask, if no, we can ask them before we summarize the lesson. Any questions, you can type it in the chat. Okay, all right. So, in summary, students, what can I say? It was nice having you. In spite of the challenges with COVID, it is important that we remember that math is a very important subject. It is very important because almost every profession, career, decision that we make involve the use of mathematics, right? So it was a pleasure for me to have you. Just remember, try to get the last 5 years of past paper questions. Try to practice a lot. And the most important thing, just be strong, especially during this COVID crisis that we have. Because in spite of everything we're going to say, 2 things. The world doesn't owe us compassion. We have to be strong for ourselves. The world doesn't owe us understanding. We have to be understanding for ourselves, right? So take good care of yourselves. It was a pleasure having you. And next year, this time around, you'll be jumping up because you have gotten your 1 in CSEC. And thanks again to Jamaica Observer for providing this facility for you. Thanks again. Hand over now to Sir Shamar. He's going to do the closing.
All right, everybody. I'm sure by now everybody can say hashtag math is fun. Thanks to master teacher Jimmy Hilton. It was a great session. Some of the things I don't even remember from when I did math, but thank God I did it already. For those who are going to do the math in CSEC, good luck. And we want to thank Mr. Hilton for coming on. We want to also thank our sponsors, Sagicor JA, Tasty Limited, and Phase 3 Productions. We want to thank you, our viewers, for coming on, and all those persons who have learned. In the chat, you can just say thank you, Mr. Hilton, and thank you, Jamaica Observer, for the platform. Thank you to our sponsors as well. Before you go, don't forget to like, share, and subscribe to our YouTube, that's Observer Clips, and follow us on all our socials at Jamaica Observer. Guys, we want to invite you to register for tomorrow's session with Miss Sonia Lee, the English language session. We're going to be here at 11 o'clock, so come out, register, so you can get your workbook. Until next time, thanks again for tuning in.
I am just a little girl, but I have big dreams. And one day, all my dreams are going to come true.
That's why I'm glad Mommy opened a Sagicor Bank Star Savers account for me.
It's the best gift she could ever give me. Because one day, I won't be little anymore. And my small savings are going to grow big.
I even got my own debit card.
Give your child a gift that will grow. Open a Sagicor Bank Star Savers account today.